Hello everyone, welcome back to another video. So if you're new to my channel, I'm Jagtar Singh and I'm an aerospace graduate who talks about aeroplanes, rockets and whatever is interesting is happening in the space industry. So in this video we're going to talk about what is International Space Station and detailed overview of some of its modules, and moreover how and in what ways countries have contributed to International Space Station's success. So let's dive deeper into this topic. So International Space Station is one of the largest man-made structure ever to exist in the space. So International Space Station is a station where humans can go, astronauts can go and conduct some of the very complex experiments which are not even possible on Earth. So International Space Station was launched in the lower Earth orbit. It revolves around the Earth at 28,000 km/h speed and it completes its one revolution in 92 minutes. Due to the strong gravitational pull of Earth, ISS would have been crashed into Earth's atmosphere, but to avoid that, ISS is periodically reboosted again and again in order to keep it in the lower Earth orbit. So in total there are 5 space agencies which have contributed to ISS like a lot. Those are USA's NASA, Russia's Roscosmos, Japan's JAXA, Europe's European Space Agency and Canada's CSA. Now let's talk about the details of each and every module. So there are numerous modules which comprises International Space Station, but for the scope of this video, we'll touch a little just on around 4 to 5 of its modules which are really very important to ISS. Starting with integrated truss structure. So integrated truss structure serves as a backbone of International Space Station because most of the modules which are connected to ISS are connected to integrated truss structure. So that serves as a backbone which supports the ISS. So there are multiple trays which are connected to this integrated truss structure. Those are called photovoltaic arrays. So these are the photovoltaic arrays which drives its energy from solar, supplies the power to ISS. So basically there were 3 launch vehicles which were used while launching ISS. There were Space Shuttle by US and the other 2 space vehicles were by Russia. Those were Proton rocket and Soyuz rocket. So these are the 3 launch vehicles which were used to put ISS into the lower Earth orbit. So there are 3 major components which has been put by Roscosmos, that has been Zaria, Zvezda and Resvet. So let's talk about these 3 modules in detail. Talking about Resvet is Russian's mini research module number 1. It serves as a basic function for the storage and it has 8 internal workstations. This also serves as a mini research laboratory for some of the experiments related to life sciences, biotechnology and fluid physics as well. So this Resvet module is attached to Zaria module. So Zaria was the first component which was launched by Cosmos and it is also known as functional cargo block. So initially this module was very self-contained and it was used for attitude operations and propulsion systems as well in the initial stages of ISS, but nowadays it is used for storage and some of the propulsion systems. So talking about Zvezda was the first fully Russian contribution to the ISS. So Zvezda module was used for providing ISS with the life support system, flight controls, data processing and some of the propulsion systems as well. So the major contribution by Canada's CSA, that is Canadian Space Agency, was a Canada arm. So Canada arm is a number of series of robotics arms which was supplied by CSS to the ISS. So there is Canadarm1, Canadarm2, Canadarm3. So these are the series of robotic arms which are used to conduct some of the EVAs. EVAs stands for extravehicular activities. That is another name for spacewalk when astronaut goes around the ISS or in order to conduct some of the experiments or in order to set the ISS. So Canadarm is also known as shuttle remote manipulator system because it is used to deploy, maneuver or move the payloads around the ISS. So after the Space Shuttle Columbia disaster, Canadarm is also equipped and paired with something known as OBSS, and OBSS is a system which is used to inspect the exterior of the Space Shuttle whenever they are coming back to the Earth to see if there is any of the damage to the thermal protection system, because Columbia disaster's major cause was that there was a damage in thermal protection system. From then only it is paired with OBSS so that there is no more such disasters. So Canadarm is actually the contribution done by CSA to the ISS. So now let's talk about one of my favorite components and modules of ISS, that is known as cupola. So cupola is a small module which was built in Europe by TASI. So TASI stands for Thales Alenia Space Italy. So it was built in Europe. So it is a small module which can be used, which has 7 windows around it. It can be used to observe other activities which are going outside of ISS. For example, if there is any of the EVAs, extravehicular activities going on, or any of the approaching vehicles, so cupola is, you can say it, a sort of observatory with which you can observe the outside of ISS, what's happening around that. This is one of my favorite components because I consider cupola as the eyes of ISS. Whatever you want to see outside of ISS, you have to go to cupola in order to observe what's going on outside of ISS. So that is the reason it is my favorite component. Talking about another module, that is US laboratory. It is also called Destiny. So it is a pressurized chamber where astronauts work actively in order to conduct many of the experiments. So there are wide range of experiments which goes on that laboratory, and that is also used for the US payloads. So in addition to cupola, I do have my another favorite component, which is known as AMSO2, and it stands for Alpha Magnetic Spectrometer. And this specific module looks out for the evidences about the particles which are coming from the distant space, deep space, which are hitting the ISS. So another module, that is GEM. So that is Japanese experiment module. It was launched by JAXA, Japanese Aerospace Exploration Agency, and it was Japan's one of the first contributions to ISS. So it was launched with the view of conducting science experiments in the Earth's orbit. So that's it for today's video. I hope you have enjoyed this video so far. So if you have, please hit the like button because it helps with the YouTube algorithm. So if you want to learn more about that, subscribe to my channel and stay tuned for the next video.